A histogram is one of the most widely used graphical representations in statistics and data science for displaying the distribution of numerical data. It is a special type of bar graph that represents the frequency of continuous or grouped quantitative data using adjacent rectangular bars. Unlike an ordinary bar chart, where bars are separated by gaps to represent different categories, the bars in a histogram touch each other because the data belongs to continuous intervals known as class intervals or bins. Each bar represents the number of observations that fall within a specific range of values, making it easier to understand how data is distributed across different intervals. Histobars help researchers, statisticians, data analysts, engineers, and business professionals visualize patterns, identify trends, detect unusual observations, and summarize large datasets in an easy to understand graphical form. Because of their simplicity and effectiveness, histobars are widely used in education, healthcare, manufacturing, finance, quality control, environmental studies, and machine learning. A histobar is constructed by first dividing the entire range of numerical data into several equal or unequal intervals called bins. The horizontal axis, also known as the x-axis, represents these class intervals, while the vertical axis or y-axis represents the frequency, which indicates the number of observations contained within each interval. After grouping the data, rectangles are drawn so that the width of each rectangle corresponds to the class interval and the height represents the corresponding frequency. Since the intervals are continuous, the bars are connected without spaces, indicating continuity in the data. The area of each bar is proportional to the frequency represented by that interval. Larger frequencies produce taller bars, while lower frequencies produce shorter bars. This graphical representation enables users to quickly understand the concentration and spread of observations across different value ranges. Histograms are primarily used to analyze the distribution of quantitative data. They help determine whether data follows a normal distribution, whether it is positively or negatively skewed, whether multiple peaks exist, or whether outliers are present. A normal distribution appears as a symmetric bell-shaped histogram in which most observations are concentrated around the center and frequencies decrease gradually toward both ends. A positively skewed distribution has a longer tail extending toward higher values, indicating that a small number of observations are significantly larger than the majority. Conversely, a negatively skewed distribution has a longer tail extending toward lower values, indicating that some observations are much smaller than the rest. Those tips may also display uniform distributions where frequencies are nearly equal across intervals, or bimodal and multimodal distribution. One of the greatest advantages of histograms is their ability to simplify large datasets into a clear visual summary. Instead of examining hundreds or thousands of individual observations, users can immediately identify patterns by observing the heights and shapes of the bars. Historic revealed the central tendency, variability, spread, concentration, and symmetry of the data without requiring complicated statistical calculations. They are particularly useful during exploratory data analysis (EDA), where analysts examine datasets before applying statistical models or machine learning algorithms. By inspecting a histogram, analysts can identify unusual patterns, detect measurement errors, recognize missing values, and determine whether data transformations are required before further analysis. Histograms are extensively used across many application areas. In education, teachers use histograms to display the distribution of examination marks, attendance percentages, or student performance levels. This enables educators to identify whether most students scored around the average or whether performance was highly variable. In healthcare, medical researchers use histograms to analyze patient age distributions, blood pressure readings, cholesterol levels, body mass index values, and laboratory test results. Histograms help physicians understand disease prevalence and identify abnormal measurements requiring further investigation. In manufacturing, quality control engineers use historians to monitor product dimensions, measure accuracy, production defects, and process variations. A well-shaped historian indicates a stable manufacturing process, whereas unusual shapes may suggest equipment problems or process inconsistencies. In data science and machine learning, historians are valuable tools for understanding feature distributions before developing predictive models. Many machine learning algorithms perform better when input variables